And there we are. So we should be live and people should be hearing us. So this is Mark Overholzer here and CoCoTECH number 3. Basically, we're going to be talking about DriveWire and some history. And I have some of the best people to talk about DriveWire, including Dr. Boisy Pete. And
not doctor yet, Mark. Almost there, but not quite.
Yet?
Oh, not quite. Can't claim it until it's there. Sorry.
Yeah, can't claim it till you get to that.
Thank you for the yeah.
Okay. What would it be? It'd be a tentative.
All right, I'm back.
ABD. Excellent. As
we're live. We're live, Mark B. Mikey Furman, PyDrivewire, and a big promoter of DriveWire is here to talk. And I have Mark B to kick me when I do things wrong. So anyway, so where are we going to start, Mikey? You're the one to kind of put this together.
Yeah. So unfortunately, I didn't have time to bring this up beforehand, but there was an email sent to the multimedia CoCo list by I think it was Chris Hawks, right? That sent the email that this year is the 20th anniversary of DriveWire. So I thought that we would start with a discussion, sort of a group discussion in between probably myself and Boisy, and anybody else wants to pop in, talk about the history of DriveWire and how we got to where we are today. So I had actually had a conversation with Boisy about this a few years ago, and I just had some notes, and I wanted to make a documentary essentially about it, but just have been doing other things. So we'll just do that live right now. What do you think, Boisy?
Yeah, that's great. Thanks for inviting me, Mike, for participating and for having me on, and for Mark O and Mark B, thank you for having me. It's good to be here.
We're glad to have you.
Welcome.
Seriously.
So, are you going to be able to spotlight my screen while we talk about this a little bit?
Yep. I will drop Boisy from the picture there and put you up big. So see if I can shift this somewhere that will be out of the way. So I tried to get Brett Gordon to come on because I know he's done a bunch of stuff with DriveWire implementations, but he's at work and wouldn't be headed home until a little bit later. So darn, because I really like Brett. Anyway, so Mikey, you have the floor.
Yeah. So Boisy, the discussion is how did DriveWire start? How did you get started with DriveWire? And you had sent me this this image here from something that actually came before DriveWire. I don't know a whole lot about Chris Decter and HS-Link. So tell us about that and how that inspired you.
Sure. So Chris Decter was a gentleman that had a booth at CoCo Fest for several years in Chicago. He was he was from Canada. I don't know where he's at these days, but he was showing up at CoCo Fest around 1993, 94, that era. And the ad that you have on the screen there, I believe that came from it may have come from a CoCo Fest booklet. I don't recall, but it's touting a product called HS-Link, which was a program that allowed you to connect the CoCo to a PC and do file transfers over an old modem cable at, I believe it was 19.2 kilobits per second. I don't remember.
Down here 19.2 and 384 and 57.6 with 6309.
Yeah, correct. And he had this demo at a CoCo Fest. I don't remember which one. I think it was 94, 95. It was quite impressive. It wasn't serving up disk sectors like DriveWire. It was serving up files. So there was a host program on the PC. It was a 386, as I recall, running MS-DOS. And on the CoCo was some type of client program, like a file browser. So that made me aware that the capabilities of the CoCo over the bit banger were more than just the always advertised and much misaligned 2400 BPS at the most, 1200 BPS reliably. And that had to do with the fact that if you're going to use interrupts to get characters in and out, yeah, you're going to be slower. But Chris was doing what DriveWire came to do, right, was to use very highly tuned, timed 6809 instructions to bang bits out and to read incoming bits. Now, I never looked at Chris's code. I didn't buy HSLink, but that was the inspiration. That was what I would consider the first DriveWire-ish type product that inspired me to create DriveWire, probably 7-8 years later, I guess, from the time that I saw that. But I do have to mention something else. There was a text file on the internet. Someone actually, not Chris, but someone else had experimented with high-speed, finely timed 6809 instructions over the bit banger. So this was not some novel concept. This had been done before. And I need to go and find that source. But that was also another source of information that made me aware that it was possible to use the bit banger at a high speed in order to get the kind of functionality that I wanted to get. So this is sort of pre-DriveWire, but with the inspiration in mind that was coming, that would later come.
So this HSLink is, you said it's more like a file browser?
As I recall, it was a file browser. It was about sending files from the PC to the CoCo and vice versa. Mm-hmm. I don't know if it was using its own proprietary protocol. I don't know if it was X modem. I don't recall what it was, but I do recall that it wasn't about booting OS 9 or anything like that. It was simply about moving files over from from the PC to the CoCo and vice versa.
Mm-hmm. So we have this HSLink, and you also said that there was somebody out there experimenting with assembly language code to push the bit banger faster than 2400. So those are the two historical starting points. Now, I don't have my notes in front of me. I just looked at them very briefly. What I saw in the notes was, fine, this happened in the mid-90s. You said around 1994 or something like that.
Yeah, that's correct.
And then what you kind of said before was you kind of forgot about it for a while. So when did it come back into your mind that you wanted to do something that led to DriveWire?
Yeah, well, the saying that necessity is the mother of invention. So in 2003, I was doing a lot of work at the time, disassembling OS 9, 6809, and creating a build environment that would allow me to cross-build Nitrous 9 or OS 9 on a modern system. At the time, I was using a Mac, I think a Power Mac G4. And so I was traveling for work back and forth to Boston from my home in Louisiana. And during my travels, I wanted to have my CoCo with me everywhere I went. So if I fly to Boston, I wanted to have my physical CoCo 3 there and so forth. It wasn't practical to put a floppy drive in my luggage. It would have gotten banged up. Obviously, heads would have been misaligned, things like that. So I began to think about how I could use the MacBook or the Power Mac that I was using at the time as a way to serve up data to the CoCo so that I could do development. And I remember I was doing a lot of work with Cloud9 at the time as well. So Mark Morlett and I would brainstorm about how this system might work. And I recall the bit banger code that I was just referring to and Chris Decker's HSLink. And I began to put together over time software on the Mac written in C and assembly language code on the CoCo that would allow me to test out this idea of reliable transfers between the two at high speeds using the bit banger. And the appeal to the bit banger was that you didn't need a serial pack or anything. You just had a cable. On one of the cable was a 4-pin DIN that would plug into the bit banger port. On the other end was a 9-pin DB9 that would plug into a USB to serial cable on a Mac or PC. So I began to experiment with code, and I didn't get it right the first time. I looked at looked at the assembly language routines, or rather the assembly language code, and counted up the cycles and timed a way to throw bits out over the PIA to the bit banger in such a way that they would be timed. I wasn't using any type of hardware analyzer to help me. I was really experimenting somewhat blind. But I eventually came up with a routine that allowed me to go at, I believe it was 57.6 on a CoCo 3 at regular speed. And I want to say that it was 38.4 initially on a CoCo 2 and a CoCo 1. We can get later about the limitations hardware-wise on a CoCo 1 and why 38.4 is the max unless you do a hardware fix. But that was the initial experimentation with the code that I had at the time. And I think that in 2003, so this is in the 2003 timeframe, when I was traveling back and forth to Boston, I created enough of a minimum viable product called Drivewire 1 or 2 that I began selling it through Cloud9 with a cable and as a package that you could load up and use to basically eliminate the floppy drive. And so just real quickly, the way that Drivewire worked then and works now is that the protocol is such that the CoCo is always the initiator and the PC is always the responder. The CoCo will ask the PC for a disk sector, 256 bytes of data. It'll say, I want this sector at this for this sector number on this drive. So drive 0 through 3, sector 0 to 2 to the 24, and go get it for me. And then, of course, the PC, which is much faster, has a file that you associate with the drive on the PC, and it says, okay, I'm going to seek into that file for that distance based on that 256 byte sector, pull out that 256 bytes of data and shoot it across the wire to the CoCo. So very much CoCo initiated, because the bit banger, the code I was using was not interrupt driven. The CoCo was not going to respond to a server initiated command because there was no interrupts. The CoCo would issue the command and then wait for the response and timeout if it didn't get it within a certain amount of time, but sit there and cycle. And then by that point, the PC would have gotten the data and sent it over. So it was very much this CoCo starts, PC responds to the handshake. There's a little bit of back and forth depending on what the particular transaction is, but very much, like I said, CoCo initiated. And that's when I realized that the speed at which Drivewire ran it wasn't quite as fast as a floppy drive transfer, but the fact that you didn't have the seek time that a floppy drive had almost kind of bit into the time that it took for the floppy drive. So it almost evened out in terms of speed. And then and we could talk about going into Drivewire 3, when I increased the speed even more, well, that brought it Drivewire much more in line in parity with the speed of a floppy drive.
So before we move on, the screen that I have up here is from June 29th, 2003 on the Cloud9 website. And this was, so according to your timeline, this would have been around the very first time that Drivewire was put up for sale. As you said, we call it in industry MVP, minimum viable product. So this worked. It worked well enough that you felt that you could sell it, right?
Yeah, you said that was in June of 2003.
This web page. I don't know exactly when you did it, but this web page capture in the Internet Archive is from June 29th, 2003.
Yeah. So about the middle
my
of
picture might be covering up the date. So
no, I see it. Yeah. So yeah, that's right. Yeah.
Mikey, Curtis asked maybe shrinking your web browser a little bit so you can see a little bit more. You can just see the top of the header and a little bit of the text at the moment.
Really?
Yeah.
Yeah,
Is
maybe command minus will shrink the text in the web browser, I think.
Yeah.
There you go.
There we go.
See a little bit more of it. Yeah.
Oh, you should have
win,
said
Curtis.
something, guys. I can't. I didn't have time to plug in the second screen to see what I'm actually showing. So sorry about
Okay.
that.
I wasn't sure what your intent was, so I wasn't going to bug you.
Is that better?
So
Yeah.
you can see more of the
A bit
text
better. You can see more of the text. Yeah.
and the whole URL. So
Okay. So I'm sorry about that.
no.
Okay.
So this
this,
does it have a version number? You're occluding part of your image is occluding part of the text, so I can't tell. Is there a version number associated with that? Does it say DriveWire 2 or 1 or just DriveWire?
No, this is just DriveWire. I have there's another one.
This looks like the
and
archive.org.
So we get to DriveWire 2.0. This is now 2008. Now I don't
The
know.
DriveWire 2.0 came out way before then, but
Yeah. So
that
this
particular page,
2005. It just says DriveWire, and then there's a gap in the archive. I mean, we jump from 2005 to 2008. So what's the timing on this one?
I don't recall.
approximately?
I don't recall. Maybe 2008 is when DriveWire 3 came out, but I didn't realize there was a large gap between DriveWire 1 and DriveWire 2. If that's in 2005, that's March 20th, 2005. Is that what that says?
It says September. It says September.
I'm looking at
This one is March,
Okay,
and then
so a couple
I
of
can
years,
just click
yeah.
this and see what happens.
So
2007, at least on Cloud9's website, it still shows just DriveWire, and then
maybe we
get
didn't
to
update the
2.0 here.
website, but I could have sworn we were past 1.0 by that point. Anyway, I don't remember the differences between 1.0 and 2.0, but between 1.0 and 3.0 is where it stands out, the big difference. But before we get into the version number, it might be interesting to talk about the name DriveWire, right? And how it came to be.
Sure.
To be honest with you, go ahead, Mike. Mark, go ahead, sorry.
No problem. Mikey, Curtis asked if you could shift your image on your screen over to the left side so that you're not occluding the text. Because it's
stand by a moment.
I know.
Let me redo this, and then so I can actually see what I'm doing.
Well, while you're doing that,
and Boisy, while I'm doing that,
kill time.
Why don't you explain?
Sure. So, when you create a product, you want a nice fancy marketing name, and I could not think of anything to call it other than, well, I'm using a physical wire, a serial cable, to emulate a disk drive, and so called it DriveWire. Incidentally, and Mark Marlette will remember this, probably, I don't know, 5-6 years after we called it DriveWire, a company with the same name reached out to us with some type of legalese email about infringing on their name. They were I think they were an auto parts website where you could buy auto parts from them, and they were called DriveWire. Well, we just ignored the email because we knew that we had been out for a while and that there was no confusion between a software product and an online auto parts company. So, but anyway, that's the name. It's kind of stuck. It's called DriveWire. It's been DriveWire since then. And had I thought about more of the impact it would have had and the lasting impact it would have had, I probably would have put a little bit more thought into the name. But
I think it's perfect.
That's what it is. It's kind of rolls off the tongue.
The thing is among CoCo people, it's like when you say DriveWire, they go, "What's that?" And then you explain it, and they go, "Oh," and then they just know it. For Apple, we have something similar where we can transfer disks from a PC called ADT Pro. So when I talk with Apple people, got a CoCo, okay. Well, it's like you have ADT Pro, you need DriveWire because that's the equivalent on the CoCo. Oh, okay.
Yeah. And so the name it's somewhat indicative of the functionality. It's not like some people call, they'll call a software product, I don't know, banana or chicken wire, whatever, just some weird name off the cuff that has no bearing to what the product is. Yeah, something like that.
It's early in the phone book that way.
Yeah. or a code name or project name will become a product name. Anyway, that's the story behind that. Oh yeah, I can see your screen a lot better now, Mike.
Yeah, no,
So-
I plugged in the second monitor so I can actually actually move the stuff around.
Thank you, Mikey.
So DriveWire 2, let's see here. It says that it's 38.4
me
on a
move
CoCo
you.
1 or 2, or blazing 57.6 on a CoCo 3. So at DriveWire 2, I was still using the handicap routines. They weren't optimal. And so the CoCo 3 was still at 57.6, and the CoCo 1 and 2 was at 38.4. I believe it was DriveWire 3 where, and what Darren Atkinson actually came and gave me some routines that were highly optimized, and I've got to give a shout out to Darren for that. But Darren shared some code that was better in terms of the timing than I had done. And that's when we were able to push the CoCo to 115.2 and bring the CoCo 2 and the CoCo 1 with the hardware requirement fix up to 57.6. So that was DriveWire 3, but DriveWire 2 was still at the slower speed.
And we get to, so this is still 2009, still not selling DriveWire 3 yet. So
yeah, maybe it came
there's
out.
some gaps in the time here. So this is 2011. We've skipped a couple of things because you were selling DriveWire 3 for a while, and then after some time it wasn't making, you can tell the story, but it wasn't making money and you just gave it away. So let's finally get to DriveWire 3.
Okay, so DriveWire 3 2011, and I'm stretching my brain here. As I recall, yeah, that's
this page says 2010, but
okay.
the website timeline might be a little bit different than
this is the
what
absolute last point in time that it would have been updated. It could have been updated. It could have been this way before 22 December 2010. So yeah, so several things motivated me to release DriveWire 3 for free. Number one, I was selling it, I think, for $30 copy, and it was taking so much of my time to support it that I felt like for the amount of I was selling it and the number of copies I was selling, I might as well just give it away, let people use it for free, and I don't have an obligation to support it, because when you take people's money, obviously they expect you to
commitment.
Support it, right? And for some people, support is a bigger burden than others. So I had decided. I talked to Mark Marlette about it. Another reason, which is probably unfortunate, and I don't want to hash up old stuff here, but there was a bit of a rivalry between myself and Roger Taylor.
Yeah, I have a little bit about that, so we can get to that.
I don't hold any ill will to Roger now, but at the time there was a little bit of animosity about some things that with the product he had came out with that was competing, and I don't want to get in and hash into it, but we probably have different perspectives on it. But I hold nothing against Roger. I really don't. And at this point, that's water way under the bridge. But that was another reason to say, look, you know what? I'll give it away. It's done. So with those two reasons in tow, and what turned out to be a really nice reason was that if you're going to have a product that the community is going to really embrace and adopt, it's good to have it out there at no charge so that people can extend it and expand it. And we can talk about DriveWire 4 at that point. That's where that comes in. But anyway, that was the motivation behind giving it away. And I believe at some point we updated the Cloud9 website to reflect that we had given it away, or that it was free or something.
I have that here. I don't know if this is exactly when this happened. This capture is from February 2011, and
now free.
You already have DriveWire 3 now free.
Yeah.
So
that's right.
So this particular DriveWire 3 page is from 2010. So you already have the faster 115/200 speed routine from Darren Atkinson. And so besides the speed, what else was added to DriveWire 3.
At
It's a
some-
fairly significant difference. It's like it really got a lot more mature when you got to DriveWire 3.
Well, the speed was the big thing. The other thing that happened, and I don't remember when, well, HDBDOS was extended. That was probably earlier, I think. But obviously HDBDOS, which is a special version of RGBDOS, which was the original hard disk basic for the CoCo 3. When Ken Tynan was selling it for SCSI drives that it was marketing back in the late 80s. Supported the RS-DOS side of things, and then there was an OS9 driver that I had wrote for DriveWire. At some point, and I don't remember when this happened, but I started creating and emitting special binaries so that you could load HDBDOS for DriveWire over cassette. And I had a minimal version of a ROM called DW3DOS. This had to be with DriveWire 3 now I think about it. So that you could do it several ways. You could take the 32K ROM out of the CoCo 3 or the 16K ROM out of a CoCo 2 and replace the motherboard ROM with DW3DOS. And when you turn on the CoCo, it would automatically basically do a DOS command over DriveWire so that you could have a CoCo that would just get all of its intelligence from the server right away, typically booting OS9.
Yeah.
Or if you wanted to,
I can show that later.
Yeah, or if you wanted to be minimal, really minimal, you could use a cassette tape or an MP3 player or something like that, hooked up to a CoCo 1 or 2 or 3, and clone them in HDBDOS and bootstrap yourself up to DriveWire that way. Yeah. So yeah. In fact, I see that ROMpak, and then there was a ROMpak. I think I had sold a ROMpak too as part of the product mix.
I bought one of your ROMpaks actually. I have. I don't know where it is, but I don't know if I really ever used it. But I bought one.
I got criticized by folks for taking old ROM game cartridges and cannibalizing the ROMpaks for the cases. So, and this is another story, but I think it's been what, maybe 5, 6, 7, 8, 10 years ago. Mike Rowan and John Linville and I pulled our money together and made true plastic injection molded cartridges for the CoCo, which we didn't do way back then. It was probably a lot more expensive. But anyway, I was cannibalizing old game carts for the cases. Yes, I'll admit it. It was a cardinal sin of mine.
Honestly, who's gonna miss the follow-on Daggerath? I mean,
or backgammon, right? Or
backgammon,
or color baseball, which they were.
Scripts
I get it. Scripts it. So the other thing that we sold was a serial cable. Mark and I think I had started making those, and Mark makes them now. But yeah, there's a plethora of products around the DriveWire product. That's it. Yeah, that's the new cartridge, the red one. Yeah, it's really nice actually. Yeah. Okay, thank you. I still have a bunch in my in a warehouse that I have. So anyway, get rid of those.
Still selling them?
Yeah, I haven't. I mean, they're for sale. I just haven't. I've got like probably 500 or something, or 400 or something crazy like that.
You should plug that.
I need to. Yeah. So anyway, yeah, I see that the cable, that was the other thing. And then of course the servers, right, Mikey?
Yeah.
You want me to talk about that? You want to bring that up?
Yeah. Sure.
I don't want to take over, so feel free to.
Oh no. Maybe we can demonstrate some things. So let me switch over here. Yeah. So I have to find this window over here.
Yeah. I see PyDrivewire.
So let's see.
He's got a bias.
What do I got here?
Sure, I get it.
I'll smack him around next time I see him in person.
Looks like you can't open a serial port.
Right. I have to plug it in. So I only have one. USB extension over here. I needed to have two. So let me plug that part in. Okay, that'll be better. So I just plugged in. I can actually just hold it up here in front of the camera. I have a USB serial adapter, right? And I just have a short little serial cable with the DIN plug that goes into my CoCo. So I just plug this in, because our modern machines, of course, we don't have real physical serial ports.
That's right. That's right.
So
Unfortunately.
hey, this is still loading Nitrous 9. Stop that. I might have to turn this off and turn this back on. All right, we'll do that.
It's funny, as serious Microsoft is about depreciating parallel ports and serial ports, they still make them.
Okay, so we can bring this server up now.
Oh yeah. Okay,
Except the window is, you know, there may be some rendering problems here, because I think I have a whole bunch of debugging in this.
I saw that. Yeah, we talked about that yesterday.
We'll
Sure.
I could here, let me just quit this. I don't remember if okay, well, fine. We're gonna have rendering problems, but so this is the DriveWire 3.0 Unix server. I think you also had servers for Mac and Windows as well.
Yeah. So this was the first server that I wrote, because there's a server component that reads the disk images on the host system and serves them over the CoCo. This is written in C, and I had written it for Mac OS, which is BSD based, and using the curses library for terminal control. And it ran, of course, the same source code compiled under Linux. So this was a Unix based server. It served, as you can see, it supported disks 0 through 3, so 4 disks. You would press the number, I think, and type in the path to the disk you want.
I literally just did that. Users.
And as soon as you press enter, then it associates that disk with that drive. You set the serial port, the mode, which mode was backward compatible, that 2.0. I think that's where it switched over to 57.6 for CoCo 3 and 34 for CoCo 2. There was a print command, which looks like a combination of pipes for TR and LPR to support printers. And then, of course, you had some statistics on what was happening with the traffic. So this was very early and very minimal, but it worked. And then in around 2007 or so, I was working a lot with a Pascal compiler called Delphi.
Delphi, yeah, I remember that.
And that's what I wrote the Windows server in. The server for Windows is in Delphi. And then I have a Mac server, so I'm a Mac user primarily. So I wrote a Mac-based server in Objective-C, which I call DriveWire Mac server, which I still maintain to this day. Although I do have a Swift server that I've been working on that is also functional right now. So, but anyway, yeah.
So I didn't realize that the Mac server is still Objective-C.
Yeah,
I thought you would have, given that I think you wrote a book about Swift. I think I thought you would have gone to Swift already, but
yeah, I didn't.
You had other things, other irons in the fire, right?
yeah. But I did recently, like at Tandy Assembly, actually started earnestly on a Swift based DriveWire server, which I will be using and extending further. That'll be the future of the DriveWire server for the Mac. But anyway, yeah, this is the original server.
So, can just fire this up and make it actually do something. I know that some people don't know this, but I have a CoCo SDC here, and I'm running SDC-DOS. It actually has a DriveWire built into it. So if you type the drive command, 0 and 1 are disk images, virtual disks that are on the SDC card. And currently, number 2 and number 3, they clearly say I'm set up for DriveWire. But I don't want. I don't think we're going to get into the intricacies of HDBDOS here, but it's drive 0 slot 2, and that's not what I want. I'm just going to change it. drive2. So I want DriveWire drive number 0, slot 0. And so I can get a directory of drive2. And when I do this, we should see the server actually do something. Yeah, you can see that it said the last command was a read command. So this is Nitrous 9 boot disk. So
this is actually reading from disk 0, correct?
Yeah, it's
Right.
SDC-DOS is configured. When I go to drive 2, it's reading from DriveWire, drive 0, partition 0.
Right.
Remember the partition is just the 360 sector offset. So I can just go here. Now that I have this set up on drive 2, I can say DOS 2, and it will go off and actually boot Nitrous 9 over this serial cable, over this USB adapter, connecting to the computer on the other side of the room. And there it goes.
Yeah, it's picking up the sectors. So
and you can see on the screen over there, you can see the sectors go by. So
yeah, there it is. Yeah, get stats and set stats are flowing through as well for informational purposes.
Yep.
Yeah. And so think about what this did, right? This eliminated the floppy drive, and it made booting from booting OS 9, which was a floppy task or a special hard drive ROM task up to that point, much easier to do without additional hardware. Now, incidentally, people say, well, some people criticized DriveWire and said, well, you're masking interrupts to do the bit banger logic, right? You're doing finely timed assembly language routines to bit bang out or read the bit banger in such a way that it's timed with the loops that are used and constructed by the assembly that I wrote. And that's true, you are masking interrupts. You have to, because you don't want an interrupt to come in and mess up with the timing while you're doing a read or a write. But incidentally, the faster you can push the bit banger, the less time you spend anyway reading or writing a sector. So the advantage is to be as fast as possible. And whenever I went from DriveWire 2 to DriveWire 3, when I doubled with Vern's routines, the speed at which the data would flow back and forth, you were basically cutting the time, not necessarily in half because there's some overhead, but you were cutting the read and write time a considerable amount, and making the operating system even more responsive. So,
yep. So, we're not going to sit here and watch this the whole time, but I was doing some speed testing using the command megaread. So I have drive. The screen is a little messed up over there, but I have drive 1 is
a
random disk. So get the date.
Yeah.
And then megaread. You need to get from x1 and need the raw device, and then get the date again.
Yeah.
And this is going to take a while, so we might. If we want to see how long this takes, we should probably talk about something in the meantime.
Well, let's talk about megaread. There's a slight flaw in how we time this, right? There's a lot of slop in this timing. Ideally, what would be nice is if the kernel would, it could be done. It could be easily done. Have the kernel allocate, say, a 32-bit or 24-bit value inside of the system globals that would increase by 1 each time a clock tick occurred, which is 60 times a second. Capture that 32-bit or 24-bit value, right? Megaread would do this in code, capture it, do the megaread, and then capture it again. You have to account for the fact that when you type date, when you surround or guard the megaread with dates on either side, you've got fork times that come into play. The date command is also bounded by the number of seconds, so you could be off by, half a second or more. So you're not getting the exact time. It's going to take. It's pretty good. I mean, it's an estimate. You could run a number of times, get an average, of course, but
While we're
gives you
waiting for this, I'm gonna show
barometer.
you something something funny over here. This is actually the source code for megaread, and if you look at it, it actually gets the time, but it doesn't do anything with it at all.
And that's better than forking date, but it's still going to give you only up to the second granularity. Ideally, you
Yeah,
want the operating system, you want the kernel to handle a timer. I actually I have some code that I had wrote for the kernel to do that. I
Yeah.
just haven't put it in
And it does it again at the end, but it doesn't do
Yeah,
anything
it doesn't
with
do
it.
anything with it, right?
I was thinking about trying to do something with that. But yeah, using a timer from the kernel would definitely be better. So
Does megaread does not mask interrupts either, right?
no.
So that would be
Believe-
another thing that megaread could possibly do to ensure that no other code is running during the megaread process is mask interrupts.
as
then
long
of
as that
course
doesn't cause any other trouble.
I don't offhand, I can't think that it would. I mean, obviously things would be halted, but I don't think it's going to mess up with the driver. The other thing too is you're measuring the time going up through the kernel IO man down into the file manager and the
Yeah.
driver and all of that round trip stuff. It adds up, right? You're not getting the true pardon my saying, balls to the wall timing on that. It's just kind
Of course not.
got some slop in it. So
It wouldn't be that hard, I guess, to write a test program to
yeah. In fact, what you could do is you could use the DW read and write routines directly and bypass the driver completely to get the absolute best possible speed, truest speed measurement. That'd be one way
I
to
think
do
I
it.
should actually do that.
That is something you could do, Mikey. You could do that, man. You could do that.
Hey, Mikey, Curtis says, check the docs and source for VRN. That capability is already there.
What's the
VRN, Victor Romeo November.
Oh, yes, VRN, I think it was part of the King's Quest stuff. Is he saying that the timing, that the large timer is in VRN? Yeah, that may be possible. Yeah. I would argue that that's something the kernel should do in cooperation with the clock, but yeah, I mean, it might be a way to get that as well from VRN. I never thought about that. Probably through some type of a get stat where you could, but again, you're calling into you're going through the construct of the kernel and the IO subsystem to get a 32-bit value they could simply read if it was more directly available in system globals. But anyway.
Yeah, Curtis said before that he said, what is it? $F copy mem to grab the tick counter.
Yep. Yep, you could do that. Yes, you have to do that in level 2. That's correct, because in level 2, the system globals are in system space and you're a user state program. You just can't go and peek the system globals directly. You have to use F copy mem to copy stuff out of the system area into your user space, which again is another set of system call overhead. The best way to do this, Mikey, would be to write a special mega read that pulls the data right from the DW read that DW write does.
Yeah.
So anyway.
And you got to
honest,
Salvador Garcia.
But as a relative
38
comparison,
seconds.
This is pretty good as a relative comparison.
Mm-hmm.
So what we took 2 minutes and 30 something seconds here, right?
I don't have looks like, yeah, 30, 38, 37, something like that.
So we can keep that in the back of our mind. That I can get a screenshot of this actually.
And this is obviously not hard drive speeds, no doubt, but it's a compromise. It's a poor man's hard drive. That's what it was envisioned to be. And for me, it was a way to not have to tote a floppy drive around in my luggage over a plane.
Yep.
So, and for debugging, that's what the main thing was. It was a means to an end. I was using DriveWire to test out my disassembly and reassembling of the Nitrous 9 source code as I was doing the commenting and getting the build system together. So.
Okay. So we took a little tour of the DriveWire 3 Unix server. So let me pull one thing up here, and then we can move on and talk about DriveWire 4 a little bit. I think that website is still up.
There should be one on SourceForge.
DriveWire 4. Yeah.
We're a little under an hour right now. We're doing great, Mikey. So keep plowing on.
Uh-oh. I need two-step verification.
Uh-oh.
I will need to come back with the phone because it's not here. Be right back. I will see what drops and disconnects as I do that.
Live demos, right?
Hey, at least nothing's blue screen so far.
So what is he planning on showing?
The DriveWire 4.
Yeah, okay, yeah.
I'm just trying to bring up the DriveWire 4 website.
He needs second authentication in order to continue.
That, yeah, that's another story that is interesting to tell.
Actually it's gone. So
timed out.
No.
So DriveWire 4 was actually a third party.
Website's gone. So let me use the Wayback Machine.
It's on the Wayback Machine. DriveWire 4 started.
Website name.
It wasn't
Aaron Wolf from Java.
Aaron Wolf.
Yeah.
I actually know a lot of history, even though I'm new to this.
Yeah, so Aaron Wolf. So DriveWire 4. So DriveWire 3 was out, and I had pretty much done what I had set out to do with DriveWire. It served my purposes. It was serving the purposes of other people in the community. There you go. That was using it.
Yeah, I don't know where the other website is. So let me keep trying. Let's keep talking. Let me
I'll talk
to find it.
Do your work. I'll talk. So Aaron Wolf showed up around 2009 and told me he wanted to write a DriveWire server in Java. Had some great ideas. I said, go knock yourself out, go have fun. He came up with an idea that I thought was cool, and that was using to extend DriveWire outside of just for disk services and print services to do networking, having virtual serial channels. Mm-hmm. So we sat down together and we thought and brainstormed it out. And there was this thing called the Winter Warm-Up Retro Challenge in 2010, I believe it was. And I've got it. I looked it up recently. I have it on my website. I think I have a link. I may have a link on my website that I think of as I think about it, Mikey. If you go to, let me go to pete.org authorship. And I think I had set this up recently. Or maybe I was looking at, I had come across this recently. Anyway, the Winter Challenge Retro Challenge Winter Warm-Up
2010
was a little contest where you could submit an idea and then, I don't know, win a mug or whatever. I don't even remember what it was. So Aaron had this idea, why don't we add networking, TCP/IP networking to the CoCo 3 and OS 9 through DriveWire. So we sat down, we designed an architecture, and we wrote a driver called SCDWV, I think, or SCF DriveWire Virtual was what it was, a virtual serial port. Came up with a bunch of descriptors, N1, N2, N3, N4, all the way up to N14, I think. This was under OS 9. And and then extended the server and the protocol so that the CoCo could open up under OS 9 an end device, and then that end device would talk to a multiplex channel on the server side, and the server would handle the TCP/IP connections and ferry the data back and forth over to the CoCo. So from the CoCo's point of view, it just had a path open to a serial port, and the TCP/IP stack was on the server side. So there was no heavy lifting on the CoCo at all, but it gave the CoCo the impression that it was on the network. It was pretty cool. So we wrote a telnet client. We wrote an inetd server on the CoCo, which again used the virtual serial aspect of DriveWire 4. And that's how we won, I think, first place in that retro challenge, winter warm up for that year. So, and that's on the Wayback Machine too, somewhere, Mikey. I looked it up a while back.
That's
So-
the website I was looking for. This
Yes.
this website has
Yes.
died. So
Yes. And this was a good product. It was. Now, Mark Marlette's going to disagree with me because he's always had trouble with Java, and there were some people. It was somewhat of a pain for some people. I personally didn't use the DriveWire for Java server because I had these other servers I had written, and I'm a Mac guy, so I preferred to use that. But there was a lot of functionality built into this, and Aaron did a great job visually in the UI design as well as the functionality to make DriveWire 4 very accessible to people.
It supported the
Yep.
Apple too, also.
It did support the Apple, yeah. And I think he did the Liberate 09 when I did that as well,
Yep.
2012. And if we can just fast forward a little bit, I think someone, is it Rocky Hill?
Rocky Hill.
yeah,
Worked on updating this because it got way behind. Java kind of passed it up, and
Well, the serial drivers I think got depreciated and
is that it got deprecated, yeah. So
deprecated.
Uh, yeah, Rocky Hill, I think recently, and I haven't used it, but I understand it works a lot better now. So
What I understand is he
This is all
unpacked
mine.
all of it and replaced all of the parts that had been outdated for the serial. line,
yes, yeah,
And then he repackaged it, and he also packaged it with OpenJDK, I think. So
nice.
literally, there is a single download you can grab. It's like you want it, just download
Yeah.
it. Mikey's PyDrivewire. It's like download it,
Yeah.
start it up.
You're done, right? You don't have to fight with all kind of dependencies and the
Yeah, it's-
JDK and this and that. Yeah,
Yeah.
which is great.
The
Thank you,
right
Rocky,
map,
for that.
whatever it is. Yes, thank you, Rocky.
well, I'm not finding it. It is on GitHub actually. I guess I didn't start it.
Yeah, Rocky's
project.
work is on GitHub. That's correct. That's
Yeah,
my understanding.
Cuban
I don't
coffee.
have that handy, unfortunately.
Cuban coffee,
Right.
but I'll get it all on the
Yeah.
show.
So this time frame is sort of we're getting into the mid to late. Like I know we were playing with the Java server like 2006, 7, 8 around there, and it sort of kept going until 2014 to 2015, something like that,
Mhm.
right?
That's right.
So I did use the Java server, because mostly before 2008 I was a very heavy Linux user, so Java was okay. And then after 2008 I switched over to Mac finally, and I still use the Java server. I tried my darndest to get any version of the Java server running on my Mac, and I was not able to. Period. The old one, the new one, nothing. It's pretty much dead. For Mac users anyway, unless you have a virtual machine. So yeah, I wish I could I wanted to actually demonstrate some of the features that are in here, making outgoing connections, and the terminal window thing that's built into it has MIDI built into it, has
Yeah,
all kinds
that's
of
right. Yep.
kinds of cool features.
That's right.
It's actually a lot for me to kind of catch up with for PyDrivewire. It's
Yeah.
actually a lot.
Yeah,
So,
he did put MIDI support in. That was
Mhm.
really nice. He did expand. I think he did something like Epson
yeah,
printer emulation or something.
yeah,
really
Epson
crazy.
FX80.
Yeah,
I
it was really wild.
So there is some Python code that can do that, but I have to get PyDrivewire up to date with the latest version of Python before I can as soon as I do that, I can add MIDI and this there's a printer module thing that somebody covered in the news. I don't remember what printer it was. Was it a Curtis might remember, but I have to go mine all of the CoCo Nation news to find that thing, so I don't remember where it went. But
Something else that I
so
remember that he did, sorry to interrupt, but he did
yeah, go
virtual
ahead.
windows. He did virtual windows on this as well.
Yes, there is not any demonstration of that. But what we mean by a virtual window is, you know, if I switch back to my CoCo, right? We have a, you know, 80 by 24. This is a CoCo 3, 80 by 24, you know, terminal window. What the Java server actually has in it is, if you open a, I forget the name of the device. Is it
Z.
Z?
Z, yeah.
Yeah, a Z. Okay. If you open Z1 or Z2, you can actually send a shell to one of those Z devices, and it will open a window on your computer that's a terminal back to back
The
into your
CoCo, yeah.
Nitrous 9. And I actually have some code for that already written in Python. It's just not complete.
Right. You would need a
I had
GUI
trouble with
component for that.
I had some trouble understanding the Nitrous 9 terminal control codes. There's
Mhm.
some minor differences in between level 1 and level 2, and I got a little confused, and I was also at the same time translating it to curses or end curses or whatever,
Right.
translating from the OS 9. So because you have to use, that's what I was using. So I have some code kicking around for that when I can get all the pieces together to do that.
That would be cool to see, to have a text-based window that you call like a terminal. That would be a virtual window that would understand the control codes that were part of the CoCo 3 to do things
Yeah.
like move the cursor around. That was really cool. So you're right, you could have multiple virtual windows popping up on your Mac or your PC running the DriveWire Java server, and have shells to each one. And was a lot less expensive memory-wise, because the CoCo didn't have to backstop the memory with any kind of text. It was just, from the CoCo's perspective, it was just serial data being sent
Yep.
out. And that's really why the CoCo 3 windowing system was designed the way it was, with those display codes, so it could run in environments just like what Aaron had created with the Z devices. Yeah, that was pretty cool. I have that kind of working in the DriveWire Mac server, but it's sort of an undocumented feature, and it's kind of buggy, but it's something I want to do with Swift, and it's really, really cool.
Yep. I as I said, I already have essentially a terminal emulator written in Python that understands OS 9 control code, sort of. That's kind of what I have written in Python. That would be the basis of that window thing.
I would love to see that.
But the Java server actually did the graphics and everything, I think.
Yeah, it drew
do a lot
the
of stuff
characters.
with it.
It did. It really did. Yeah. Something else that, not really related necessarily to the Java server, but something that Aaron had started but never finished, was an RFM file manager for Nitrous 9. And what that would do, that lifted the file, it sort of abstracted out the file system on the host, so that under OS 9 you could CHD to not to a block device that the host was using as a disk image, but actually on the file system, the native file system on the host itself. So I would think of like NFS, if you will. And it exposed the OS 9 $open, close, read, change dir, make dir, del dir file manager calls in a way that it would use DriveWire and communicate that over. And so you could mount on Nitrous 9 the host file system and see it and do dirs and things like that. It's pretty cool.
Hey, Mikey. Curtis reminded me
Yes.
that Bill Noble, one of the developers on Nitrous 9, uses the virtual window feature all the time. And recommended we might get him on here sometime to show how he uses that, since it is.
Yeah, it'd be great to demo it. It's unfortunate we don't have DriveWire Java server running to show it, but it's really cool.
Okay, well, we might have another show out all this on DriveWire, so maybe.
I mean, I think
get him on here.
I think it should run properly on the only Linux machine I have handy is a Raspberry Pi, or I didn't really have time to pull up a virtual machine. So
I found the SourceForge link actually from Boise's DriveWire server, which his new one, which we'll get to eventually, I'm sure.
Yeah.
So I was able to link to it, and I posted that in the chat as well as the Rocky Hills.
Do we want to take a brief break?
We can if you want.
Sure.
We're about an hour in, so do another hour. So yeah, we'll take a little break.
I know you probably don't have commercials or anything fancy
I
handy,
do.
so
I have everything from the main show, so I'll just fire off commercial number 1, or I think it's number 0 actually. So
all right,
let's
then
roll.
I'll be right back. Whoops.
No problem.
Hey, Amy. Hey, Taylor. We're watching the Coco Nation show. Yeah, we are. Woo! You should too.
Hello everyone, it's your good buddy, your good pal Amigo, and joined by that dastardly The Brent from ARG Presents.
You're watching Coco Nation.
I feel like that should have been longer.
The Coco Nation Show would like to thank the following patrons: Alex Gayer, Brendan Donahue, Brian Walsh, Brian Weasler, Kieran Anscombe, Coconut Bob, Daddy Burrito, Diego BF109, Don Barber, Eric Canales, Glenn Hewlett, Graham Wabke, Grant Leedy, Henry Strickland, Justin Larson, Ken Reichard, Kevin Holloway, Patrick Euland, Paul Fiscarelli, Paul Shoemaker, R. Allen Murphy, Retro Tech Time, Rob Inman, Rocky Hill, Steve Batson, Terry Steege, TJ B. Chris, Tom C., Tom Gunderson, Tom S., and William Athing. Thank you so much, patrons.
Okay, we're back, Mikey.
Cool. So we covered pretty much the history so far from very beginnings of DriveWire all the way through to the Java DriveWire 4 server. And sort of the next thing that happened was as it got increasingly harder and harder to run Java, I started actually making PyDrivewire in Python. I was doing everything in Python in my day job, and I never really did any Java programming at all. Never ever even liked it. So Python was where I went. And well, I don't even remember the history actually. I would have to go back here all the way to the end.
And you've got the history there. You can go all the way back to the first.
I have the entire history, so it should be 2014 or 15, something like that. A lot of commits. Oh, 2016. All right, a little bit later than I thought.
So I remember
in February 28th, 2016.
I remember when you started working on this, and I've always been a proponent as the creator of DriveWire to see more people do something on the server side, on the host side. So when you had announced this, I thought this is great. I'm all for it. We weren't competing in any way with, the more servers, the better in my mind. And turned out that, well, my concern initially was the speed at which the server might run, right? Versus the C-based one, which is probably the quote unquote gold standard in terms of how fast something can go.
Yep.
But I think you knocked it out the park, right? I mean, eventually you got it running very fast.
Yeah, there's actually there's actually a trick to that. And that trick is right here. It's called PyPy.
Mm-hmm.
So Python is first and foremost an interpreted programming language, just like BASIC. You type in the program, and it's a little bit different than BASIC. As for Python, you open a text file, you write your whole program. When you run the script gets interpreted, and it actually gets compiled into bytecode. Very sort of similar idea to Java.
Mm-hmm.
So if you run regular Python, just the Python command, see if it doesn't find PyPy, it'll try to run with regular Python.
Mm-hmm.
And so regular Python is the interpreter. When it runs the script, it compiles it and runs bytecode. PyPy is a different animal. What PyPy will do is, when you run the script, it'll compile the bytecode, but it actually has it actually does just-in-time compilation.
Right.
So it will, while your script is running, it will keep track of what code is running and how often it's running. And if you run it, these are all things that are configurable. I've never done any tuning, but it'll actually take the Python bytecode, and it'll compile that into native code. So it's no longer doing bytecode interpretation. It's actually running native code on the CPU, and that's as fast as you can do with Python, unless you take your Python code and convert it to C or something else.
Right.
So that's the trick that makes it as fast as it can be. Now, it's still not going to be as fast as Java or C or even the Swift one. Python currently has a problem that it doesn't really do multitasking or multiple threads. It kind of only really runs one thing at a time due to locking inside the interpreter.
Mm-hmm.
So, but
I would argue that
with today's computers, they're so fast. I still only have a M1 Pro, but it's fast.
Well, I was going to say that with modern systems, Python as an interpreted language is still very performant. And just the convenience of being able to change the source code is, because Python is a fairly ubiquitous language. You don't have to compile it. You just make the change and rerun it. And it's easy to, it's quick to go through the iteration of making changes, seeing those changes on the fly run, and doing it that way. So yeah, I think PyDrivewire it's a great innovation, and I salute you for doing it. I think it adds to the pantheon of DriveWire servers, and it's a worthy part of it. And I understand a lot of people use it. So
yeah.
And plus, you've done some excellent stuff with deload support, which is another great feature that I never delved into that you tackled and did well too. So
yep. There's a deload server. It does a MC protocol for the MC10. The Java server can only do telnet. PyDrivewire can do SSH. I have all the necessary support to actually work with Dragon computers as well.
Mm-hmm.
VDK images, DOS plus.
I have some questions around that.
Yeah.
So a couple of questions. I never did really focus on the Dragon for Drivewire. Are people who use Dragons use Drivewire? Is it pretty common on that platform?
I don't think so.
Floppies weren't that common. It was expensive, and so a lot of people didn't get the discs. For the Dragon.
Yeah, but people just loaded stuff from tape back in the day. But I don't think very many people use DriveWire on the Dragon. I think the most hardcore users do.
Mm-hmm.
So they have a they had like a DriveWire module and an SD card module that plugs into the parallel port, I think. Because the Dragon 32 have a parallel port as well? Or is
I
it
don't
only
know.
the 64? I don't remember exactly.
I have a Tano
the
Dragon, which
Tano
is
has
the
it.
USB. Yeah, the Tano has the parallel and the serial port.
With the 1651.
Yeah.
And
Like,
actually,
I have one of those.
parallel port would be nice. And an implementation of DriveWire with a parallel port would be super fast. In fact, I did that with an Arduino. I called it Arduino CoCo. That was back in 2016 or something, 2012.
That's actually an interesting project by itself.
Yeah.
Hey, Boisy, where does Ghidorah fit in with this? I know that you did that as an add-on.
Yeah. So, yeah, thank you for mentioning that. So, yeah, Ghidorah, which is the multi CoCo project. That was more of an experimentation. What I did is I took the DriveWire bid banger routines and I put them in a ROM, and I came up with the physical cable, think token ring for serial, where the TX line of one CoCo would go to the RX of the next, and the TX of that one would go to the RX, and you sort of make this 5 or 8 ring token ring thing. And what came up with a server, I guess for lack of a better word, based in Python, in fact, that sat in the ring along with the CoCos, and it would be the arbiter that would communicate and send code out and load each of the CoCos up with code. You could actually individually address each CoCo by number based on where it was on the chain, or you could actually tell every one of them to load code at a specific address. And that was there was really not a lot of utility for that, although it's kind of a cool idea. But how many people have 4 or 5 CoCos with a special cable they have to build to well, maybe it would work for you, Mark. Maybe it's something you should play with.
I've got 2 CoCo 3s, 2 CoCo 1s, 4 CoCo 2s, and a Tano Dragon.
Yeah. The hard part of that is the cable. The cable was
special cable,
hellacious to make. And Jim Brain actually made a product. I don't think he productized it, but he has it.
Yep.
I had a couple of prototypes where you could connect 4 CoCos together pretty easily. And yeah, I mean, it's a solution looking for a problem, kind of, but it was fun to do.
So is that
kind of like, I want to ask this, Mark. It's kind of like a CoCo version of a Beowulf cluster in a way.
Yeah. So actually, there's something for the Apple II that works the same way, using the built-in I/O on the joysticks. It's called not a net. So Boisy, not a net. Yeah. So you built that into your versions of DriveWire that are standalone in C, right? And we haven't got to that yet, but there's another set of servers that Boisy has. You just put out in the last couple of years, as I recall.
Are you talking about the GitHub page that I created?
Yes.
The GitHub? Yeah.
Yep.
So what that was just a consolidation of all the different servers that I had. They were all separate GitHub repositories.
I have those.
I wrangled them into one repository, and there was something on SourceForge that I had pulled in as well. Maybe it was hosted on SourceForge initially, and I wanted to get away from SourceForge because I don't use Mercurial. I use Git, and I don't like to have to. Everybody pretty much uses Git, especially at work and in industry. So I brought that over. I brought the source code over from SourceForge, kind of reclaimed it because it kind of gotten out of my hands. And then that's all it is. It's basically just a reorganization and a consolidation of repositories around one, what I would want to call the official DriveWire repository, which has the Mac version of the server, the Windows version, the Linux version, not the DriveWire version. I didn't do that. And Rocky Hill has the latest on that. So yeah, so that is what I'm trying to make the quote unquote official DriveWire site for improvement. And the Swift version is up there as well, I believe.
I actually don't know about that.
Yeah, if you go to github.com/ my first name, Boisy /DriveWire, it should be there.
I'll throw it up. I had it up here earlier when I was looking for the DriveWire 4 one.
No, that DriveWire Unix is no longer the case. All those are It's just oh, there it is,
this
right
one
there.
here,
Yeah, that's
the
it. Yeah.
official home of DriveWire.
Yes,
Okay,
correct.
got another star. That's how I'm going to find it again.
So there's the C, the Delphi, the Objective-C, and the Swift version. Right. The
Nice.
Delphi, of course, is the Windows version, which I haven't compiled that in years since I don't have Delphi anymore.
There's actually an open source one for Delphi that's called Lazarus.
Yes, Lazarus. Yes, I haven't
posted it
used that.
earlier.
But I'm aware of it. Yeah,
I
and maybe
was-
it'll work on that, Mark.
Yeah.
I don't know. It'd be interesting to try it.
Yeah, it would be. I worked with it a couple of years ago. There was a guy a Commodore 64 guy, and he wrote a Yahtzee program that had a client that ran on Windows, and then he also had one that ran on the C64 using a hardware NIC. And so it's like, cool. I'll help.
That
you
is
test
neat.
this. Yeah, and
Yeah.
so his server was written in Lazarus basically, and I said, hey, could you make this command line and compile it on Linux, because it was Windows based also. And so he did that, and so I could run it on a Raspberry Pi or my Linux system. So I run on the Mac too. So yeah, it's cool. You run the server, and then you can have a C64 client and a Windows client. So
Yeah, it's just Pascal, so it should work. Now, the DriveWire Windows Delphi version there was a lot of GUI component to it, so I'm not sure how that would transfer on Lazarus, but
I believe there's
wasn't
some
command line.
libraries that are added to it for that.
someone
so.
should take that up. I'm not a Windows guy. I won't do it, but someone is free to do it.
Cool. So, yeah. Let's just finish up with talking about PyDrivewire with what are my plans for the future.
Yeah.
So we'll just go there.
What are your
So-
plans?
Unfortunately, I have not converted PyDrivewire to Python 3 yet. The last couple of years, I just haven't really felt it.
Yeah.
But it really needs to be done.
Yes.
The last release that I did, it got very, very difficult to figure out how to get everything working on Mac and Windows and Linux, for everybody. So that is something I really want to start working on soon. I think I need the Flex stuff to die down a little bit, so I can have a little space to get into that. So it's middle of November. We have December coming up. I kind of want to do something interesting for that. Yeah, see, all these things keep coming up. I need to just sit down, buckle down, and do it and get it done so I can move on. Once PyDrivewire gets to Python 3, there are a lot of things that I can actually do. I will be able to add MIDI support. I will be able to add the console window support that we were talking about earlier. I will be able to add those things to it.
Yeah.
And once it has those two features, PyDrivewire will be more or less on par with the Java server as far as what features it supports. There are a lot of additional features, as we discussed before. So those are my immediate things that I need to do, is just get off of Python 2 onto Python 3 so I can move forward. And then I really think that there is a PyDrivewire right now, and I will show a demo in a little bit using PyDrivewire instead of Unix server. But basically, it's a console application in the traditional Unix way. And I sort of was able to bolt a web page onto the side. It basically, the web page just has a connection into the interpreter, into the command interpreter, and the web page can send commands into the server. The server doesn't really know whether it's coming in from the standard in or standard out, the main one, or whether it's coming in through the web page. I'm really kicking around in the back of my head the idea of going full blown on the GUI side. And I think at least the way that I see it, using web technology is probably the right move. Because then I don't really have to worry about, I can use WX widgets, or Python has TK built in, but those are so old fashioned. Actually get something, something that's 21st century.
Could you do multiple windows through a web GUI? Could you do that? Could you have like virtual?
Of course, we run web applications all the time that open up different windows, right?
Okay, all right. So it could be done. Yep, sounds like the way to go then. And I think it would be quite performant on a modern system. So that's more reason to do it.
I had a crazy idea today. Was it today or yesterday? I don't remember. That I might be able to find a way to run the entire server in the web browser, and then you have a little client that you run somewhere on on a computer somewhere, on a Raspberry Pi, on a whatever, that actually does the communication, something like that.
Well,
it was just a crazy idea.
You could probably write a DriveWire server in JavaScript.
Oh, that's not really something I would want to do.
No, not saying you want to do it, but it's
in
possible.
The browser.
Yeah. So, but anyway,
that would make it a lot easier for me.
So that type of approach would obviate the need for the servers that we have now, right? You want to go web based, which is fine. I like having all choices, right? But it would certainly be interesting to go that route. I think it's great. I'd love to see that as an option.
Mm-hmm. I wouldn't abandon command line, but I think there are just some people who would, pull up a terminal, and I don't have this window. Where are you? Whoops. Where am I? I'm getting lost here. Quit. Oh, it won't stand by. I have to plug the USB cable in again. There are some people, to finish my thought, there are some people who don't really do command line at all. And if you tell them that something is a command line application, they're like, huh?
Yeah.
Where's what button do I push?
Right.
So I mean, this is let me make a tiny adjustment here. There we go. When you run PyDrivewire, you have a command line.
And that was something that Aaron's DriveWire 4 also did too, as well.
Right. I didn't happen to turn on the web page. Let me do that. One moment.
Yeah, that's a cool feature of your server as well, as you can interact with it through a web browser.
It's also inexpensive because you don't have to spend a lot of time building the page or standalone for it. So,
come on. $6,800. So if I just add that, so the PyDrivewire server is running here. It's connected to this is queued up for the next demo. But if I go back to the web page and I open up there, so this is the PyDrivewire web page. Now this is a combination of HTML and I'm sure very poorly written JavaScript, because I'm not really a JavaScript programmer, but it's just enough that you can change what this inserted here. There's a little confusion about this. So this is what I currently have. This is what I meant by if I push a button here and I look in the command window, you can actually see if I suppose I wanted to put this disk into drive 1 as well, just click insert. You'll actually see in the command window the web page actually sent this command to the server.
Right. Yeah.
And then after that it did a refresh, so then it sent the show command to the server and interpreted. This is kind of a dumb way to do it, if you will.
It's a novel way to do it. I like it because you're using the same path that you would do if you typed it. So you're just letting the GUI be the typist in this case. I like it. It exercises the same code that you would exercise if you did it through the
right.
command.
It's cheap. It's just sort of reusing what I already have. The right way to do it would be to have an API layer where maybe, since it's web technology, maybe use JSON or something, or some kind of RPC thing or whatever. But yeah, so that's what I did.
No, this is awesome.
Manual.
It's usable right here. I mean, it is.
Yes.
That's the beauty of it.
The other thing I like about PyDrivewire is he has everything all packaged up in a single download. So
Yeah.
you don't worry about futzing stuff. The game that Brett, Gordon, and Jay Searle have been working on called Alcaran, I use PyDrivewire 6.6 all the time for the transport for both regular CoCo and for a Becker port, basically. And because it's great, you just download it. I got the command line parameters are right in the manual. You just copy and paste them out and adjust them for your system. And hit the button, and it just works. Really nice.
Now, one thing I'm doing with the Swift version of the DriveWire server is I'm trying to really focus on separation of concerns and architecting it in a way where the model of the protocol is isolated in its own class versus having knowledge of what the physical interface that goes to the CoCo is. So the DriveWire server model knows about the protocol, but it does not know if it's talking to a serial port or any other type of I/O system. It uses delegate methods to sort of pass information back and forth to another class that gets the data from the DriveWire server, sends it onto the CoCo through a serial port or whatever other physical mechanism there is, and gets the data from the CoCo back. The other thing I'm doing with the Swift version of the DriveWire server is I'm using obj.c, which is Apple's documentation system, so that I can produce documentation for people who would want to take the Swift class for the DriveWire model and incorporate it into their own app. So there's an advantage to having native code for a DriveWire server if somebody wants to go native with it versus having it in the way that you're doing. I think both ways are valid. It's just some people have a choice or preference rather for app-based versus web-based.
Yeah, I might do an app as well. So I'm not sure. We'll have to see. I need this to be 0, actually. All right.
Are there any other areas of DriveWire we haven't covered? We talked a little bit about your standalone servers, Boisy. And
the history we covered. Mike did a great job of going over the sort of surveying that. There's of course the work he's doing, the modern, what I call the modern DriveWire server implementations. I don't know if you want to talk a little bit about the future of DriveWire in terms of what can be done beyond what's already been done.
I've penciled these things out to be about 2 hours. We're an hour and a half in, so
that's fine. Yeah, and I can just quickly touch on that.
Yeah.
And Mikey, you can bring up some ideas, but DriveWire does networking, it does disk services, it does printer services, it does virtual serial ports,
MIDI.
MIDI. What else is there for it to do? I don't know. I mean, it could go faster, and in some cases it does go faster because I'm working on this F256 Phoenix computer, which is a 6809 computer that runs at 6 megahertz that Stephanie Allaire created under her brand Phoenix Retro Systems. And I've got a DriveWire running at 230.4 kilobits per second, so double the speed that the CoCo runs. So you can maybe push it faster on systems that can accommodate a faster serial port, even a parallel port. In the case of the Dragon, would be great. It's really about this at this point. The functionality that DriveWire covers is pretty robust, and it's about making the servers, like what Mikey's doing, more convenient, more accessible for people using the technologies available on the host side. Mike, what do you think?
Yeah, I was busy. Sorry, I actually was bringing this up.
Oh yeah, that's the is that the Windows version?
No, DriveWire
It's a
for
Mac-
Mac server.
Oh, Mac server. Yeah. Okay. Yes.
So
Yeah.
this is the Objective-C one, right?
Yes, correct. And it has networking support, as well as the virtual printer and drive support. Yeah, which I don't plan on doing anymore with the Objective-C version. My focus will be on bringing the Swift version as the new modern implementation for that platform for the server.
Yeah, you have.
So I have one statement from the chat and one question.
Yeah.
So Brett Gordon basically said he would look closely at lwwire, which is William Astel's little server version that he put together. He says it has an interesting interface for adding new protocols without clobbering the old DriveWire interfaces. So
I'm familiar. I've seen lwwire. I don't know. Is it it's a server? Does it expand on the DriveWire protocol in some way? Does it change?
Yeah, it has extensions.
Okay.
Yeah, C code, I believe.
One of the extensions it has is it has some kind of ton tap interface, so you can use it actually to send and receive Ethernet packets. I've never used that for anything. I don't completely understand how it works. Actually, I did look into it for a little while.
So the DriveWire protocol space it's not completely exhausted, but there are. It's based on opcode, right? So you have, an opcode to read a sector, an opcode to write a sector. It's a byte, and then there's other bytes that follow. So a byte is 256, 0 to 255, basically 8 bits, right? So there are a couple of more spaces in that DriveWire opcode table that are available. You could extend out, and we've done that to a certain degree in DriveWire, where you take an opcode and then you add turn it into a pre-byte, much like we do on the 6809 with certain instructions that add a 10 hex or 11 hex, and then the next byte is the other opcode under that pre-byte domain. You could do something like that.
Scott threw out video streaming, and then Curtis's question. He said the Gimme X may be able to slam the bitbanger at 230, 400 baud. Will the bitbanger hardware in the CoCo 3 handle that? If the CPU could handle that?
I don't know. That chip is the salt chip is responsible for that, and I do know that Darren Atkinson had put together some bitbanger routines at 230.4 kilobit per second. They required that the CD line on the bitbanger was hooked up. I don't remember the exact technical reason why, but I believe it can. The CoCo 1 is that we haven't touched on that, but I want to touch on that. So the CoCo 2 can go to 57.6. The CoCo 3 can probably go to 230.4 kilobits per second without any problems, because I know Darren Atkinson had done that. So yeah, I think that's physically possible if we could. I don't even think you need the Gimme X to do that. I think it's doable now, but the code gets the timing gets even tighter, and there's less room for error every time you jump up in the speed that you want to push the bits back and forth. Let me just touch on the CoCo 1. So the CoCo 1 was at 38.4 kilobits per second, whereas the CoCo 2 is at 57.6 kilobits per second in DriveWire 3. There's an op amp on the CoCo 1 that had a slew factor that prevented it from handling 57.6 kilobits per second. But it's documented that you can take that 8-pin op amp out and replace it with a modern version, and your CoCo 1 can then do 57.6 kilobits per second. So it can be as fast as a CoCo 2.
It's a CoCo 1 is a 741 op amp. That's not fast.
Right, but you replace it
with
the modern one, right? And And it's easy because they're socketed. You just take it out and replace it with one, and it'll get automatically upgrade on the speed.
One thing that's good about the salt is basically Pedro Pana knows Rocky Hill. He basically has a replacement module called the pepper chip, which replaces salt. And I'm sure he's used more modern components. You know, if that was a limiting factor, probably swapping in one of those would probably get to the edge.
The original salt worked though, the 77266 or something like that. But yeah, I'm aware of Rocky's upgrade. Mark Marlett has something called a micro salt, which I don't know if he's released it yet or not, but I know he has. It's been at least a prototype. But yeah, there are replacements for that chip, which is a very customized C that is not easily sourced.
Yep, I know. One of those unobtainium things.
Yeah, getting close to that.
Brett also said
So-
taking advantage of handshaking would be a blessing.
Oh,
Not
yeah.
that the code serial has much of that, but other connections do.
What was it?
Oh,
Handshaking?
Handshaking, yeah. Brett was saying
Yeah,
that-
one. Brett is asking about using handshaking, and the Java DriveWire server actually does support using RTS CTS. That's an option that you can turn on. PyDrivewire also supports that. I'll actually show that when I get to my next demo. I'll actually show that being used. Handshaking, that's one of the gripes that people have about DriveWire is that there is no handshaking, and the CoCo is in control, and there's no way to send anything asynchronously to the CoCo. That's sort of those are the 2 or 3 different lines of things that people complain about the way that DriveWire was designed.
Well,
So
that
that's
was
sort
by
of what Brett was
design.
referring to.
That was by design due to the limitations of
Yeah,
the bitbang, right?
It was.
Yeah, you have to people have to realize that what you're doing with DriveWire on the Bitbanger port is far beyond what they ever expected to do. I mean, what did they expect? 600 bits per second for a printer?
Right. Yeah, right.
That's-
Or
that was
maybe
That was the target.
yeah, maybe 1200 BPS under OS 9 level 2, right?
Yeah, exactly. So
And the protocol, the DriveWire 3 protocol introduced a new op read extended command to even better allow the CoCo to control that exchange. The CoCo was always the initiator. So and just touch on how we did networking, and this was another ingenious thing that Aaron Wolf did, is so you're doing networking right on a CoCo 3 or CoCo 2 running DriveWire 4, and data comes in. Well, how does the data get to the CoCo asynchronously if the CoCo always has to initiate the transaction? So there was a virtual interrupt under OS 9 where the interrupt would interrupt a driver 60 times a second, say, hey, you know, run your interrupt service routine, So Aaron and I came up with a way in the DWIO subroutine module. We installed an interrupt service routine, and it was tickled 60 times a second by the virt. That interrupt service routine would send a byte out to the bitbanger and ask the server if it had any data for any channel, and the server would respond back either no, in which case we wouldn't ask for another second or whatever, or it would respond back with, yes, I have a byte and here's the byte. So that's how we transferred data from the server to the CoCo over the network, over the virtual serial port, was by this polling mechanism, which was granted not the most ideal way, but it worked, and it still works quite well. So
Curtis pointed out that there was a printer, one of the printers could handle 2400 CGP 220, but still,
was it emulated by DriveWire 4?
I don't know. That's
no, it's the Epson FX80.
Okay, what's the printer he was talking about that you just mentioned?
CGP 220. It's a Radio Shack line printer, I think.
Okay.
So, and the other thing too is that the DriveWire port's only output. I mean, it might output 2400 bits per second, but it only gets back handshake response. It doesn't usually get back a stream of data. So.
Oh, he's talking about what other printers are supported on the bitbanger?
Yeah,
Yes.
just what the
Yeah.
target
Yeah.
of the bitfinger was.
Oh, right, correct. Yeah, that's right. And the DMP 130 and those types of things that had the
So
4-pin DIN.
those are way slower than anything.
Yeah, they weren't. Radio Shack wasn't even thinking about doing what we were doing with the bitbanger.
Yeah. So there you go. We're getting away with a lot of stuff here.
Yeah. But I think if you get away from the bitbanger, DriveWire there's nothing that has to say that DriveWire has to run over the bitbanger. It can run over a true serial port with interrupt-driven fast buffering. It can run over a parallel port. And there are things that you could do to extend the protocol to make it more bidirectional. So.
And if I can ever get to it, Ethernet.
Yep.
TCP/IP connection over Ethernet.
Yep.
Very much so.
Then there's there's Drive Wirelessly, which is another interesting product that we didn't bring up. This is the wireless version that
we don't have Sloopy, so
there's a demo you wanted to show, Mike.
Yeah. So if I zoom this thing out, let's see if you guys can see that.
It's okay, Boise, because I figured I wanted to try to keep these to like 2 to 3 hours. So if we've got the virtual windows with Bill Noble and the Drive Wirelessly with Sloopy and maybe some other stuff, we got room for another hour or two.
Yeah, I've got a hard stop in 15 minutes, so
that's fine.
Yeah. So here's my make sure I'm not tripping over any wires here. Here's the CoCo 3, and I have a MegaMini MPI, which is this one here, and plugged into the side of it, this little box on the side here is actually, if I move the Ethernet,
right?
move the Ethernet cable out of the
is that the CoCo IO?
This here is the CoCo IO, yes, but
Okay.
I'm not demoing that. I can just unplug it.
Got it.
But this little module here on the side is the USB module for the MegaMini MPI. So that basically MegaMini MPI has two 16550 UARTs in it.
Mm-hmm.
And they connect to the port on the side. There's a pin header there. And Ed Snyder sold I don't know if I'm sure he could build more of them. This little box has a board in it that has two FTDI modules in it.
Mm-hmm.
So it's converting TTL from the UARTs. UARTs are in the MPI TTL connection, and then that goes over USB. And then I have the USB connection over here going back to my my computer.
Right.
And as far as I know, nobody had really done anything with that, except actually I have. So what I'm going to demonstrate is I'm actually going to demonstrate. I'm going to be using DW load that we mentioned earlier.
Mm-hmm.
Let's see. You guys see that screen pretty well?
Yep. It says collect demo drag.
So PyDrivewire side, server debug. Let's just put 1. So this PyDrivewire server was run with serial port right here.
Mm-hmm.
So this serial port is the USB serial port. I'm running at 921.600.
Almost
and if you see here, I have handshaking enabled.
Right.
Because the handshaking is necessary.
Right.
As I'm sending serial data at 921K, and the CoCo can not do that at all.
Right.
So I have the UARTs in here. The USB connection is connected. On the CoCo side, I have a disk image over here called DWDOS.
Mm-hmm.
And if I get a directory of this one, I have a whole bunch of different ones. I can. Bitbanger. Bitbanger. This is what you were talking about earlier, Boise.
Right.
The DW load, I think you call it. This is just the bin file version because that's more convenient for
Right. It's not the
software
ROM
development.
version.
I can
Sure.
redo it, and so I have the CoCo 1 version, the CoCo 2 version, the CoCo 3 version for the Bitbanger, RS-232 pack version, and then I have my 2 versions. The MegaMini MPI has 2 UARTs, so 1 and 2. So all I really need to do here is
You're loading this off the CoCo SDC right now, right? Okay.
I am currently running it off the CoCo SDC.
Got it. You're gonna load that binary off, right, off the CoCo SDC.
I could have loaded it off of the other cable, but
right. Well, no, I just want to sit.
I don't have don't have them both connected at the same time. I could.
Yep. Okay.
And then if I exec this, what it's going to do is the PyDrivewire window is going to start doing stuff. This is going to provided I have the correct disk image. Let me just make sure.
Make sure your disk image is correctly set up, right? Yep.
Yeah.
Looks like it's the MM.
It has MM. It has
so this is a
there. So
6309 version of Nitrous 9 with the MegaMini MPI DriveWire driver in the boot file, so that it can. Okay, got it.
Right. Yep. And when I tested this yesterday, this worked. This was not the buggy one I was talking about.
Cross fingers. Cross fingers.
Is it working?
At least we know it won't.
I don't see anything happening.
No, it should have triggered something by now. It should have said Nitrous 9 boot.
We may have a demo fail, which is okay.
Reboot everything.
Yeah, let's just redo this. This guy is plugged in over here.
Because I'm anxious to see how this 921.6 kilobit per second speed is going to impact the speed of booting. And
okay, and it's that's the correct.
Didn't give an error on loading the serial driver, so
let's turn on the full debug.
Okay.
It's possible I ran the wrong thing. Let's just do it from here and see what happens. Plugged into port 1. It says failed.
Failed.
Okay.
So
well,
it communicated.
That's it. Doesn't work.
Did you fix the problem that you were talking to me yesterday about the checksum being off by 1?
I have to.
That's not what's showing up
doesn't
here,
look
right?
like it.
Okay, all right.
It would have said right here. This would have said 243 or something.
Right. Okay.
So it
looks like you got the checksum
everything was
F8
correct,
back. Everything looks correct, right?
This does not look like the correct sector.
Doesn't look like this looks like the DOS sector. Yeah. 264
this is not
the
a
right
DOS
offset.
sector. So
do you have the disk image set up properly? Did you build it properly?
HDBDOS is false, is that right?
If it's a 256 byte image, it should be false, I think, yes. There's no offset that you're adding.
This is correct. It asked for the correct sector.
It's just not getting it served to
okay,
it, right?
I don't know why this isn't working right now, but all the other times I did this, it worked fine.
When you ran it yesterday, was it considerably faster with the higher
Oh,
bar?
yes. A lot faster.
Nice.
So I really don't know what's going on here. So, alrighty. Well, I guess that's the end of that.
It's all right.
I'll make a video. When I get it working again, I'll make a video.
Yeah, I'd like to see how the speed is. That would be nice to see. That's what 4 times, 8 times faster than 115.2.
8 times faster.
8 times, yeah.
So I had some math failures. I can't tell you exactly how much faster it is. I should probably write the real test program that we were talking about to get real numbers.
That would be awesome. You did DW term, which is another program you didn't talk about. You could do it in there even, right? DW term, which is a pretty cool little.
You fire up DW.
That's a good idea. If I do that, I don't have to write it in assembly language.
That's right.
I just have to write some code to DW term doesn't have anything right now that asks for sectors, but that's just a simple thing of formulating the command and
Yeah, that's
calculating
it.
the checksum.
That's it. You can ask for the
Those are the
same
only two
sector
things.
even. You don't even have to ask for, it doesn't have to be a megabyte disk image. You could ask for the same sector
Ha ha
overlay.
ha. But there's an advantage to using random data.
Yeah, that's true.
So,
That's true.
or data with bits that flip back and forth.
Right.
Oh, I think I know why this didn't work.
Okay.
Let me change this back.
Maybe it'd be,
We're trying to boot a random disk. What happened?
oh, that's not right. You
Why
had
are we
it set
trying to
up,
boot the random disk?
you had it set up earlier before.
Give me a moment, and
You want to
let's
mount the right disk in?
I have to get to this window.
So we built the image correctly. He just pointed it to the wrong disk. Darn, foiled every time.
Let's put this guy in disk 1.
Brett just mentioned in the
Okay,
chat.
that's a little better.
There's
What
a
did
few
Brett mention?
CoCo Fusix platforms that have DriveWire support.
Yeah.
Yeah, and I don't use Fusix, unfortunately. I need to get into it, but I understand that. I guess Brett was the one that did that. That's pretty cool as
He
well.
did the port
Yeah.
for the CoCo 3. Yeah. Every time I fire it up, I think of coherent Unix. It's like, whoa, this is like,
It is cool.
Okay, this should probably this should probably work a little bit better this time.
oh,
All
no.
right. Let's see what happens.
Because this did work every time I tried it yesterday. So there it goes.
Oh yeah,
Wow.
It's
much
not as
faster.
fast
Oh,
as
yeah.
SDC.
but it is still
So-
much faster than than the CoCo 3 at running the bid banger at 115 too. Oh yeah, that's amazingly
So
better.
guys, help me remember. Earlier when we were doing it over the
It
bitbanger,
was 2 minutes. It was
like,
2 minutes and 2 minutes and 38 seconds
right.
or something like that.
even with the wonkiness here,
Yeah.
input from X1.
Yeah.
All right. So when I tested this before, it was
Yeah.
35 or 38 seconds.
So what's the time there? I can't really see it. The resolution is bad.
I can zoom in on that a little bit more. I don't think it's going as fast as it did when I tested it yesterday.
Now you're probably getting some time eaten up by the scrolling that's happening on the server. I don't know how much impact that has, but if you weren't doing the scrolling,
Something
out.
happened. It stopped.
uh-oh.
That's sputtering. There it goes again.
It's still going.
It's just laggy.
Yeah. It looks like it is stuttering though.
Wow.
Okay, what is the time? I can't see the 2 times.
Let me adjust the camera a little bit here.
58 and 36, so 38 seconds. Yeah,
Yeah, it's supposed to be 38 seconds.
that's
Yep,
awesome,
was.
man. That
It
is
actually did it in 38 seconds.
that is pretty good, man. That is pretty good.
The fastest I ever got, according to my notes, was 20. So this is going over USB.
Hmm.
The fastest that I ever got, according to my notes, was I used a real serial port, a hardware serial port on Raspberry Pi, and it did it in 15 seconds.
Over using the DriveWire protocol.
Using the DriveWire protocol
That's
at
crazy.
921 with all the CTS
Yeah.
RTS handshaking, it did it it did a megabyte in 15 seconds.
So
So I was saying I was a little bit math challenged. I'm not able to figure out how I calculate. So we'll do this again with the scrolling turned off.
right, see how much, yeah.
See if it makes any difference. So here we go.
Yeah. So while it's doing that, the fastest I've ever ran megaread is I used a dummy driver that basically did nothing. So all it was really measuring was the overhead going down into the driver and coming back up. Megaread on that was, I think, on a 6309 CoCo 3. Mark Marlette and I had done this, was 9 seconds. That is the best you'll get, pretty much, a 9-second megaread.
Curtis said the original Borken hard drive controller took 45 seconds, and that was on the fastest CoCos at the time, except for 38 seconds on Frank Hogg Eliminator, but not many people had those.
38 seconds on the Eliminator, which is the same.
Yep.
So, okay. So what is that? 57 to, what is that? 24 or 34? Okay, 34. So you're still around 30, 36, 37, 38, between 37 and 38 seconds. So the scrolling really was negligible. That is a tremendous improvement over 2 minutes and 38 seconds. So,
that's correct.
That's great, man. That's a great way to end this feed, is to show that kind of
Glad I figured out what was wrong.
That's awesome.
Well, it's been about 2 hours, so we're going to call this a wrap. Like I said, when I put this idea together a year or so ago, I thought, these are going to be really concentrated, but I want to keep them fairly short. So
that's good.
Maybe up to 3, but only if it's really, really good. So we're at 2
hours.
Well,
I think 2 hours was good to cover everything. There wasn't really a lot of, it was all meat. So very little salad on this one. So
exactly. And I figured not everybody's going to want to watch this, and not everybody's going to, tune in, but that's okay.
I do want to mention, though, real quick before we go, I did a presentation on the history of DriveWire at Tandy Assembly, I think it was last year. It is on YouTube. If you go to YouTube and you search for my name and DriveWire, I did talk about the history of DriveWire with a slide presentation that kind of touched on some of the same stuff here. So
I'll roll all these things up and post them. We have on the CoCo Discord, we have basically a news summaries we use for a regular show.
Okay.
I stuck one from last week, and then I'll put one in for this week, so people will be able to go there and grab all the links.
Sure. Well, I want to thank you, Mikey and Mark, for this. This has been quite good. I appreciate the strong technical bent here and the opportunity to talk about my work and the work of others. I'm very proud of what DriveWire has been for the community over the past 20 years. It exceeded what I expected. It was a tool that I built for myself that turned out to be useful for other people, and that gives me a sense of pride and accomplishment. And I want to thank you all both for having me. It was a pleasure.
Thank you for coming on. It's like you're the man on this, and it's nice to hear it firsthand. So
thank you.
Yeah, thank you, Boisy, and keep innovating, keep playing with stuff, please.
Sure.
Some of the things you do are super cool.
Thank you. Well, I appreciate that, and thank you for what you're doing, Mikey. Bringing DriveWire forward the way you're doing. That's pretty cool. I think a lot of you for doing it. Thank you.
Yep.
And thank you both for being here. And we, a little plug. We're going to be doing next week. It should be G Shell. Basically, history of G Shell on Nitrous 9. That's going to be Curtis Boyle and Rick Euland. So
nice.
Same time next week, and should be really fun. And then I have 1 week off, and maybe Sloopy wants to shove something in there. It'd be great. And then after that, I have Mikey and David Ladd and hopefully Paul Fiscarelli talking about Grease Weasel and floppies. And that'll be 5th of December.
Talk.
Yep.
We finally get to do floppy talk. Wow.
Finally. And I said, no asparagus. I don't know if you know, Boise, but basically if people get too bored on the normal variety stuff, they call asparagus, it's like time to move on. It's like, no asparagus here. It's like,
no, there was no asparagus in this call.
There won't be. And I told them, it's like, if they say it, it's like, no, it's like, you don't like it, don't watch. So anyway, thank you again, guys. And we're going to stop the streaming. See y'all next same time, same channel.
Okay.